Welcome to The Explainer. Today, we're going to dig into a story that's hidden inside a simple set of numbers. And what it tells us? Well, it's all about the power and the absolute peril of trying to predict the future. Okay, so to get started, let's meet our product. It's a gadget launched way back in 2010, and we'll call it the flux capacitor. Its whole life story is laid out right here in its sales data, kind of like a digital footprint of its journey. Now, the big question is, can we use that footprint to see where it's going?
For 14 years, from its launch in 2010 all the way to 2023, this gadget went on a seriously wild ride. And the sales numbers, they tell the whole story.
Just looking at this data, you can almost feel the story unfolding, can't you? It has a slow start, just 1,500 units in its first year. But then it catches on. It just surges through the early 2010s, building up all this momentum until, bam, it hits this incredible peak of 14,500 units in 2017. And then, after that high point, you see a slow, steady cool down. It's a classic product life cycle, right there in the numbers. Okay, so here's where it gets really interesting. This whole rise and fall pattern, it's not random. Not at all. If you were to plot these points on a graph, they would actually form a very distinct, recognizable shape.
Right, so this is not a straight line just going up or down. It's way more complex. It's a curve, kind of like a big hill. It grows, it hits the top, and then it comes back down. And this is a brilliant illustration of what so many products go through in the real world. So the challenge, and really the opportunity, is to see if we can capture that exact shape using math.
And that leads us to a really crucial question for anyone who wants to make a prediction. If we want to look into the future, we first need a tool that can perfectly understand the past. So what kind of mathematical tool can even do that? Well, this is exactly where data scientists come in. They forge a tool to do just that. It's called a regression model, and it's basically our attempt at building a mathematical crystal ball. Think of it like this. If all our sales data points are just dots on a piece of paper, a regression model is like a super high-tech stencil that can find the one perfect curve that connects them all as closely as possible. Its whole job is to find the hidden pattern. Now, because our data makes this complex curve with all its ups and downs, a simple straight line just won't cut it. We need something a lot more sophisticated, something like a polynomial function. These equations are super flexible, so they can bend and twist to match the data's shape almost perfectly. So how do we know if our model is any good? Well, we give it a score. It's called R-squared. A score of 1 would mean it's a perfect fit, and a 0 would mean it's no help at all. And for our flux capacitor data, a really well-chosen polynomial model can get an R-squared score of about 0.92. And let's be clear, a score of 92% is fantastic. That's an A+ in any classroom. Our model is tracing the past sales data with incredible accuracy. So it really seems like we've built a truly reliable tool for seeing the future, right? Okay, with our trusted crystal ball in hand, all polished and looking pretty much flawless, let's actually put it to the test. We're going to ask it to make two predictions, one about the future and one about the distant past. First up, let's ask it to look ahead, say, 7 years from our last bit of data in 2023. What does the pattern predict for the year 2030? And the model gives us an absolutely massive number. It's astronomical. It predicts sales are going to skyrocket into the hundreds of thousands. It's suggesting this huge, logic-defying comeback for a gadget that we know was in decline. Okay, that was weird. That prediction seems totally disconnected from reality, so let's try looking the other way. Let's ask it about the distant past, like 5 years before the product even existed. And now the model gives us a negative number. It's predicting that back in 2005, the company somehow had negative sales of a product that hadn't even been invented yet. And this is the moment, right here. This is where our perfect A+ rated crystal ball just shatters. The predictions are mathematically correct, based on the curve, but in the real world, they make absolutely zero sense. So, what in the world just happened? Is our model broken? Nope, the model is fine. It was just being used way outside of its comfort zone. And this is a classic, really critical mistake in data science called extrapolation. You see, the model only knows one thing, the pattern it learned from the data between 2010 and 2023. Outside of that window, it's just mindlessly extending the curve it found, completely ignoring real-world logic. It has no idea that sales can't be negative or that products eventually get old and stop selling.
Here's a great way to think about it. Imagine you throw a ball and you track its path for a few seconds. For that short time it's in the air, its arc is a perfect mathematical curve. But what happens if you use that curve to predict where the ball will be in 5 hours? Well, the math might tell you it's 50 miles up in the sky, when common sense and reality tell you it hit the ground ages ago. The rules of the game changed. So, the big lesson here isn't that models are useless. Far from it. The lesson is that the absolute most important part of using a model is knowing its limits.
What this really means is that our crystal ball wasn't a crystal ball at all. It was more like a highly detailed map. And it's incredibly accurate and super useful, but only for the territory it was designed to cover. In this case, that's the years 2010 to 2023. The second you venture off that map, you're lost.
The famous statistician George Box summed it up perfectly with this quote. We have to remember that these incredibly powerful tools are just helpful simplifications of a really complex reality. They're not perfect copies of it, and their usefulness is completely defined by whether we understand their flaws. And that leaves us with a final thought about the countless models that shape our world every single day. You know, from the 10-day weather forecast to economic projections, they all have a map, and that map has edges. So the smartest thing we can do is always ask, where do those edges lie?